So we'll kick off. Welcome everybody. Thanks for joining Once Upon a Time in London. My name is Harry Nidger. It's been a delay in the last few shows, but we've got another one up and running. I want to welcome everybody into the room. Jan, how's it going?
Good, thank you. Good, thank you. My name is Jan Kodabash, for those who don't know me, and it has been a while, Harry. Oh, sorry, I should say I'm part of Universal Technology Solutions, and me and Harry have been co-hosting this for a few weeks now. I'm excited for this one. This one is one of my favourite topics, which is visibility. So yeah, we've got the guys from Kerbro. Do you want to introduce yourselves?
Yeah, sure. Yeah. Hi, Jan. Hi, Harry. Hi, everybody. So I'm Paul Brett. I'm responsible for Kerbro's business in the UK, Ireland, and Middle East, actually. So my role is so multifaceted, really. In terms of, but effectively to drive our business and expand our business across those geographical territories.
Amazing.
Yeah, hello, my name is Fabien Schretzmaier. I'm part of the Kerbro technical support team and also solution architect for the sales team.
Amazing. So Jan, how do you want to kick this off? Normally we kind of cover the week, but it's been a couple of weeks. So how should we kick this off?
Yeah, no, we'll just go with, maybe we just go straight into it. So we'll start with visibility and people getting access to information that's across their infrastructure. I guess this is where Kerbro, you guys are, this is one of your key principles of what you deliver. Do you want to give us a quick overview of some of your product sets?
Yeah, so I mean, effectively, what our technology role is to deliver copies of network traffic to the relevant network tool that needs to analyze that traffic to carry out its function. So in that sense, you can sort of think of us as plumbers delivering traffic from a source point to a destination point of where it needs to go. And just a bit of context around that, really, of course, as we understand, all IT networks, whether that's enterprise or whether it's service provider, need to be monitored and managed for performance to make sure they're working correctly, for security to make sure they're secure, and for analytics. So for things like regulatory compliance and planning and so on. And the devices, of course, that are used to do that monitoring, we refer to as network tools. And all of those tools need to access and analyze network traffic to carry out their function. So as I say, that's what our job is to deliver the network traffic to those relevant tools. And the reason our technology was originally developed, there are probably three high-level use cases for our technology. The first one is to remove blind spots. So every network has one or a number of blind spots, and what we refer to as a blind spot is traffic that is not understood by those network tools. And that's normally for a legitimate networking technology purpose, maybe a tunneling protocol or some sort of transport protocol that's carrying traffic across the network, but the tool doesn't understand it. If the tool can't understand it, it can't therefore analyze the traffic, which therefore the blind spot represents risk. So every network has one or a number of those, and our technology recognizes those protocols and is able to get access to the native traffic and pass that in an optimized form to the relevant network tool. And then the second, that's her first high-level use case. So of course that affects things like performance posture, performance capability, and security posture, and so on. The second high-level use case is really about reducing the loading onto those network tools. Again, most tools don't need to analyze all of the network traffic, but just a subset of it to carry out their function. And so what our technology is able to do is to optimize that traffic, filter out traffic that does not need to be analyzed by those tools, and then send that optimized traffic to the network tool. So the advantage of that means that, of course, those tools are working more efficiently. They're not wasting time analyzing traffic that has less relevance. And it also helps to right size both the technology and the price, of course, because most network tools, there's a large element of their cost is associated to capacity or throughput or usage. And of course, we can reduce that, which has an impact on cost of ownership and return on investment, of course. So that's the second use case. The third high-level use case is around business continuity and removing single points of failure. So our technology is able to load balance across multiple network tools. So in that sense, like any other sort of load balancing use case, if one tool goes out of service, then the others just pick up the function, and obviously the original, when it comes back into service, picks up its workload again. But we also have inline bypass capability. This is probably more related to security use cases, where we're able to monitor an inline security tool. We're able then to automatically detect when it's not functioning correctly or it's gone out of service. We can then steer the traffic to an alternative security device. We continue to monitor the original device, so when it comes back into service, we automatically steer the traffic back to the original device. So again, the benefits there are around security posture, so of course making sure there are no sort of gaps in the security capability, but also things like upgrades and maintenance and so on. Rather than having to book downtime on a network, then companies are able to minimize that and minimize any outage on the network. So sorry, it's a rather lengthy explanation in the end.
Yeah, I was going to say, Paul. Yeah, but I was just going to bring Harry in there. Imagine, Harry, we've talked about this before, where we've been called in to do forensics. Yeah, when there's been an issue, having all of the information at hand is where you can really start with tools like this. These are the enablers, really. You're able to get right deep into the data and actually produce some forensic or analytical detail on what the problem might have been or what the problem actually is. Without it, or without adequate visibility, you're only going to get half the story, and there's nothing worse than being called up to look at an issue and you've only got half the story. So engineers like myself and others rely totally on equipment like this.
What happens, right, Jan, when, for example, a customer brand has a problem? You come in, this tool doesn't exist. Can you retrofit the tool and then see the data in the past, or only from the point it's installed?
I mean, and Paul, let me just get to this. It's fairly easy to kind of shoehorn in a tap, even temporarily. Yeah, it's only about, and actually provides just some passive visibility to them, just to see what they're not getting. And often when they start seeing it for the first time, you know, even as passively, because by having something like this in line, you're not actually touching the actual flow of data. A lot of customers do actually look at it and say, wow, you know, this is really good. And it is quite, you know, it's not that complex to do, but it's just that, and I'll, you know, this is something we were talking about earlier, is it's amazing how many environments and organizations haven't, when I say invested, the culture hasn't invested into complete visibility. And maybe Fabien and Paul, let me ask you, why do you think there are two camps? Some that just still rely on span ports, and that's kind of like subject to kind of dropping packets, where you've got the ability to have taps and you know, enhanced visibility and get the full story.
Yeah, I'll go first, but I'll ask Fabien to comment in a second if I can. I would say my experience, it really comes down to appetite of risk, to be honest. And so, of course, you know, and that will vary according to a specific company and also certain you know, industry sectors. You know, so financial services, for example, you know, they're very heavily regulated, so they absolutely have to have accurate data. And the reason that's important is because with span ports, as you mentioned, you can't guarantee the integrity of the network traffic that's being copied and therefore is being analyzed. So again, actually what you're potentially doing with span ports is introducing blind spots. So you can't be absolutely sure that you know, your analysis, whether it's security or performance, is completely accurate. With network taps, you can guarantee you get 100% of all of the network traffic. So the network tools will be able to analyze all of the traffic that's required to carry out their function. So coming back to the original point though, Jan, as you mentioned, why do some companies have more of an appetite or go down the tap route rather than the span port. It comes down to, as I say, probably a bit of a balance of a compromise of how much risk they will accept, because span represents risk and taps don't. But how much risk would they accept as a compromise against what they perceive to be an easier deployment? Less products to be deployed, and cost, and all of those other things. And in reality, I think that's changed significantly. I'm not sure whether that's maybe an older, something that became something that was believed and has persisted, because technology's moved on. In terms of cost, the cost of deploying taps and packet brokers and those types of technology have reduced significantly. Form factors have reduced significantly, so they're much easier to deploy than maybe they were at one time, and much lower cost. So I think that compromise now actually is probably less necessary than it was, but maybe some of those beliefs are still there. I don't know. What's your thoughts, Fabien? And that's probably my experience.
Yeah, it very much always depends also on the size of the network. Smaller networks, let's say the investment to have taps is maybe dramatically compared to the risk that you mentioned. But the bigger the network gets, it also the complexity gets higher, and span ports then more pretend to cause so duplicate packets. This is also something you need to think about. You can do something wrong with span port settings, and then you cause duplicate packets. With intelligent tapping, it's more likely that you don't cause duplicate packets, and then you again save, of course, any tool costs that would remove the duplicate packet. So this is also one part. But from my experience in the last couple of years, also from our customers, when they're building up new data centers, and it's all about 100 gig, then you don't think one time about span ports. A span port of a switch or a router with 100 gig is not. We don't live in these times anymore. So we have customers that buy hundreds of taps for their hundreds of links, even if they don't want to get the data from this particular link now, but maybe they do it in future. So they're already purchasing the taps for all the links in the network from security point of view, because maybe in future they want to go there and tap it or get the data, and they don't need to change any configuration. It no impact on the network. The tap is already in place. They just go there and connect it to a tool, and they have the data without changing anything. So it brings at the end a lot of advantages to have taps in big networks. I understand the concept of span ports in smaller networks. Also for lab environments, definitely I understand it. But when you come to production in big environments, the efforts to invest in taps is definitely a good choice.
So now we've talked about like the physical taps. Now with everything turning more virtualized, and we probably have to touch on cloud, there'll always be a question of how do we kind of align what we have, our traditional methods of actually getting that data off to the virtualized environment. It's east-west type traffic. Let me ask you guys how you guys propose to kind of fix that or fix that problem.
Yeah, we have a virtualized version of one of our network packet brokers. We're also shortly launching cloud-based solutions as well that will be resident in Azure and AWS as well. So we have that capability. That being said, I would say, and certainly my personal experience is that we still see the majority of customers want to extract traffic and use appliance-based network packet brokers. And the reason being, it tends to be two major reasons. Because of performance, there are performance limitations in cloud environments. So firstly that, and then things like advanced features. So with appliance-based network packet broker visibility products, there are very sophisticated advanced features to allow us to optimize and manipulate traffic when necessary, which just aren't available in software-based solutions. So we certainly see still a preference for appliance-based, in the main. That being said, there are of course situations where a cloud version is more appropriate, so we have that solution as well. But I'd still say we still see the majority as being appliance-based. Again, Fabien, I don't know if you've sort of got any additional comments to that. That's probably my experience, I think.
Yeah, you summed it up very well. So it always also depends. Do you want to get the data out of the virtual instances, or you keep it in the cloud? And if you have your tools in the cloud, at the end, also depends on the scale. It's not necessary to have any, of course, then virtual tap or virtual packet broker. You just pull the data between the services. As soon as you say you have a physical tool, physical appliance where I want to have my data in, then you need to get the data out, and then there are multiple ways to get it out.
Right, yeah. So there's another area where people are starting to deploy, going a lot more software based on their network infrastructure with NFV type solutions. And I do like the fact that the aggregation, virtualized aggregation solutions are available, because with NFV, you're able to stitch your own transport connections. And so it, for me anyway, it aligns more to the traditional methods of actually doing it. We get everything from the wire to the device, rather than with some of the CSPs. Firstly, they've got their own different type of concepts, and we're less in control. We kind of have to oblige to whichever technology they have for sending traffic, whether it's mirroring or whichever one, GRE tunnels or whichever ones they have. So so it's good to know that they've still got the visibility, because whenever you talk about cloud product, everyone always still again talks about visibility. So it just goes to show how important that is. I'd like to just, one of the things that we began talking about, I wanted to, when you mentioned about the bypass switch, one of the benefits that I was looking to take to a customer once is well, particularly take the bypass technology, which allows you to kind of switch optically from one link to another. We had a site where we had a single internet link, but we were testing out two different SD-WAN providers. Now, with only one internet link, it would have required, every time we wanted to test that, it would have had to require a physical person going in and actually plugging it into the new equipment or the old equipment. The bypass switch solution, having that hedged in during that test phase, would have allowed us remotely to come in, have it on a normal day without any impact. We've said that before, the optical switches work just generally without any issues or latency. And then during a test phase, we can just switch it over for the internet circuit to be in line with the new appliance. So we could go through a test phase remotely without physical resource being there. And also, we've got to consider, when you're looking at optical cabling, when you're unpatching and patching, that's the worst thing you want to do with fiber cabling.
Yes.
You don't want to keep, so you want it inline, you just want to remotely do it in a controlled manner. So for me, that was a challenge we were able to kind of solve, or is able to solve for a customer. I know it's not specifically for that purpose, because it's used for tooling, but you can use it for things like that. Yeah, which
exactly, really, it's like with a railway, you just move the way from the light to another destination, and then you have a new link basically for the data to transfer. You don't need to patch anything, you just switch and the hardware does the rest for you, and it's almost without any interruption as soon as the two new partners have created their own link together. So yeah.
No,
And
I
then
think
you have to additionally in the Kubro bypasses, you know, with additional you can apply filters to remove data inline already. So this is taking also an advantage that you maybe can already block something there, which you don't want to have.
Yeah, I think what you know, that thing about people having to unplug and plug fiber cables, it's a different topic, but it's definitely major when you're working with you know, delicate fiber cabling. But so if we go just back on track with Kubro, the company itself and your product sets, as we know, we use these tools for precision measurements. What is kind of life cycle testing? I mean, you guys are based in Austria. Tell us a little bit more about the company and its principles on testing, because you know, everyone's going to be relying on your equipment. What lengths do you guys go to ensure that, you know, they've got a decent?
Yes, so there you need to separate already the two of the product lines. One side you have the taps, and then you have the packet brokers. Those are the two major different hardware lines that we launch. The taps are produced in Austria. They're assembled together by our team here, and each of the optical and electrical tap is tested in-house, and you have a test protocol of each of the tap with all the values that you have. So they are ensured that when they leave the factory here, they work, each link works inside of the tap, and you have a measurement protocol for each of the links. This is not usual to do so, because typically then you have a general measurement protocol of splitters. For example, when you take an optical tap, a general protocol, but we do a test of each tap, and the actual value of this tap is on sheet of paper,
Right.
and we provide it to you. Additionally,
is it a little bit when a provider, when you've got like a dark fiber or something from a telco, they'll do an actual test and give you those results for each circuit? Right.
Exactly. You have a test result of this product that you get. Same, we do optical pictures of the connectors and save it. So for later we can show how the tap left the factory. And at the end, a tap is so solid. If it survived the shipment and you build it in and you clean it and you connect it, it has no failure at all. It works forever, basically. Otherwise, you'd burn down the data center, for example. But as soon as it's built in, you connect it and it works. There's nothing you change, and it has a 100% uptime. It's not like 99.9%. It's 100% because it's an optical tap. At least it's no power. You know, no software on it. So it's like a cable. It works as long as you don't touch anything there. Very similar with electrical taps, of course, with power supply, that can always happen something. But with optical tap, it's very sure. Then on the other hand, you have, and from the taps, we always develop more, always develop these taps further to have more sustainability in our next product. So we always check the manufacturers of the edge splitters, the components that we buy, quality insurance, and if there is really a problem with the tap, when there are, for example, there's a quality problem of this tap, in particular, the customer will get an 8D report at the end, what has happened in this case, and what are our steps and solutions to avoid things like that. It's very important for us to have this quality, because at the end of the day, when we deliver 300 taps to a customer, we want that all of them, when they are built in, work at the time, because it's very frustrating if you don't plan any spare parts and you have 10 taps and you're building in, and one split of one tap is maybe not working. It's very frustrating at the end. So we have really high regulations on ourselves on the tapping side. The packet brokers are produced outside of Austria. but also there at the factory, each packet broker is tested and verified that the switch and everything is working correctly. Also no scratches or so, of course, from the hardware. They are inspected at the factory before they leave. And when they arrive in Austria for the final shipment around the world, each of them is again checked, applied with the new firmware. So you have always the latest firmware on it. There's again a visualized check if the hardware is okay. So if it arrived in Austria, fine from the factory, and you have a quality label again on it, and then it's going to the customer. So, and the life cycle of our products is very long. So we have products that we sold more than 10 years ago, and they're still working at customer side. And
okay, and that's supported still by you guys.
Yeah, it depends. We have, of course, products that are end of life. If a product is announced end of life, you have a 5-year support range. So the end of support is 5 years after end of life. So you have insurance that if Cooper announces this product will be not available in 1 year, then you have again in 6 years, there will be the end of support, basically. Of course, you know, hardware is changing, the new chips and everything, and at some point we replace one packet broker with another packet broker. If there's always a replacement at the end of the day. Say, okay, if a customer comes back to us after years and says they want to have this product again, and say, okay, we don't have this particular one, but here is the upgraded version of it. There you go. And then we help the customer to integrate it and to train also the people if something has changed from management perspective.
It's probably worth, Jane, sorry, just going to, it's worth mentioning as well, because we manufacture all of our own products. So they're not third-party manufactured, they're all Cubro manufactured by our own facilities as well. So we have control throughout that process.
So did are you guys affected at the moment with you know, where we're seeing some of the other vendors affected with delays in hardware shipping? How did that affect you guys, or is it still affecting you?
I mean, minimally, actually. We were very lucky. I say very lucky. We managed that well. We didn't experience significant delays, and I've seen delays of 6 months, 12 months. That those types of significant delays with some networking gear and so on, and we haven't experienced that at all. We've had some some small disruptions around some component availabilities and and so on, and we've had some. Where components maybe have gone end of life, so on, but nothing significant. And typically, of course, we have a workaround, in that instance. So where we've had maybe components that have become unavailable, because we have control of the product, we've been able to re-engineer product to work around that if necessary.
During the pandemic and during all this situation, some of the products have been redesigned. Some chips, let's say, were not available anymore, and they were then upgraded to a new product, basically, or this product kept the same, just inside of the hardware something changed, which is then fixable by a software patch to the new boxes then at the end. So this is customers maybe don't even recognize that there was a change, and in where it's since we manage it very well, products where we know, okay, there can be a problem in the next couple of weeks or months, we ordering from the factory a huge bundle of devices to have them in the inventory. So our inventory is always full. We don't, like, let's say, have only the devices that come here typically are shipped very fast again, but we ensure always the inventory need to be full with tabs on packet brokers.
Yeah, we normally
and also bypasses.
Lead times are normally about 2 to 6 weeks, something like that.
Yes,
that's our normal.
So, I'm conscious of the time. I've got a couple more questions that I want to cover, but for example, there are other competitors to yourselves or people who do something similar. What is kind of bespoke to you, or that you would say is a bit of a differentiator for your product? I mean, for me, I'd say, being able to work with a European company helps in that way. Some of the smallest form factors, aggregators and bypasses are great. But let me ask you guys what you think differentiates you from
there's a few things there. I would say, Jan, we have some unique capabilities, of course. So we have some unique products. We have a product that's a combined packet broker and tap, and also can run, it acts as a server, so you can run third-party software on the same appliance. So for example, that could then become a security appliance, but it's all, so that reduces a solution that might be 3 or 4 separate products into one product. So that's a unique capability. We're able to optimize, which is reduce the quantity of metadata. So things like NetFlow, IPFix, and so on, we can reduce the quantity of that. We have an optimization product, and we can reduce that by a factor up to about 60 times. Now that's very relevant, of course, in terms of reducing the storage required for that metadata, and also the loading on the receiving device, whether it's a security or a monitoring device.
Just before you carry on, I just wanted, that's a really important point, is of when people are looking at these aggregators, what it's able to do is to kind of not feed in the whole packet itself, but actually give enough information or cut it up in some way, so you're efficiently storing the actual data you actually need. So that you've got still maintain that visibility, but not with having to have large disk space of. But sorry, carry on. I just wanted to make sure that point was made.
Maybe I just want to add one part when you just topic that you just said as an example. Very lately happened. So we have replaced at an Austrian service provider a system which was used for many years, and we replaced the solution for the 5G upgrade. And the footprint at the end was 60% less. So 60% less hardware was used to do the same what the other solution did, plus 5G monitoring also. So we know that the electrical and then environmental footprint is a big point, and we also look at that part always. And since we very much listen to the customers, our customers, and we plan together solutions, we can build solutions exactly for their use cases, and together create something very new actually. So these are our strengths, definitely, from my point of view.
I think it's a good point. The last point actually I was just going to mention was sort of along those themes, which is that, and actually our technical architecture is different to most of our competitors. So we use very advanced ASIC technology. And that's the root actually for a number of benefits that differentiates our technology. So with the ASIC that we use a Tofino chip, that we're able to build in more functions into the chip. Well, what that means is we need less processor power in the box, or separate CPUs. So more of the functions and the advanced functions are done in the programmable chip, which gives us performance benefits because it's just in and out of a chip then, rather than going into a CPU. It gives us power benefits, so we use less power because we don't need as many CPUs in our solutions, and it also reduces our footprint because CPUs take up more space.
Right.
It also allows us to devolve more of the advanced capabilities out across the range of products. Because our products typically we have small, medium, large, if in general terms, and with many of our competitors, other solutions, what you will typically find, they'll have a hub and spoke type architecture. So the really intelligent advanced features are in a centralized type device, probably chassis based, and then they'll have relatively dumb feeder boxes that feed traffic into those. And what that does is limit flexibility of deployment. What we're able to do, because of our more advanced technology, I would say, is we're able to devolve those advanced capabilities out to our entry-level products. We have a range of products that start at entry level from probably £4,000 or £5,000 list price, and that includes some of those advanced capabilities that you would normally only see in a centralized chassis-based system that might be costing £150,000, £200,000. So that gives us more flexibility about how we can deploy our solution to meet our customer requirements. So I think those are probably some of the key differences with Kubro. Sorry, the last point actually I forgot to mention, which I should have mentioned a bit earlier, was that also gives us very significant price benefits as well. So typically, our pricing is between 30 and 50% lower cost of ownership compared to our major competitors. And that's partly because of the technology we're using, partly because of the footprint and so on. It also allows us to do some very clever things, like we can transmit and receive at the same time on the same port on a product, which again our competitors typically can't do. So that helps to reduce footprint as well. So from that technology, it helps to reduce our cost, helps to reduce our footprint, and helps to reduce the power consumption, which again, and then overall has a very significant total cost of ownership benefit.
Okay. All right. I've got one more question, but just on that cost part, Paul, I'm going to hold you to that when we do our next order, actually. Hopefully we see some of that benefit. But what are we going to see? So we now understand, the benefits of using taps and the visibility of the aggregations devices, the cost benefits, and also the efficiencies of transferring that data. And the enhanced visibility, the two camps we've talked about, people not actually having the full story, and this equipment having, giving you the full stack, and arming engineers with the right information when they're troubleshooting. But lastly, what I'd like to, where are we going to see, what's the next step for this technology? What are you guys looking at next? You don't have to tell us exactly, maybe, but where do you see it?
Again, I'd ask Fabien to comment in a second. I would see what we're seeing more of now, I guess, is more advances in things like deep packet inspection, which sort of leading to, if you like, more intelligent application management and application, or I should say application traffic management, whether that's, intelligent filtering and so on. So being able to understand more about the characteristics of the traffic and then make decisions and optimize the traffic on that basis, or on the application type basis. We can enrich that traffic as well with additional intelligence, typically security intelligence. So I think that's an area we're seeing more demand in, and an area that we're continuing our developments in, to give more capabilities about how do you, it's not just about now visibility and delivering traffic and delivering that very efficiently, which we do. It's now about adding additional value through that deep packet inspection. And I would say the other area is actually around those efficiencies of traffic, because as the amount and quantity of network traffic is increasing significantly, that's an ongoing challenge, which obviously has, apart from a cost impact, a technology impact, in terms of, if you want to be able to be able to monitor and secure all that traffic, you need to be able to store it, then analyze it, and so on. So again, what we're seeing is more focus into that optimization type capability, reducing the quantity, but retaining all usable traffic that's then sent to the network tools. Did I miss anything, Fabien, from your point of view? You think that?
Yeah, of course, encryption is a big point. How to handle more and more internet traffic or data is encrypted. Also, there our DPI comes into our hand. How we handle that part of the data. So there is a lot of new stuff with Kubro. So the next few years will be very exciting. The steps we can make. Also, what we see when we speak to customer now is all the privacy regulations for the countries, and it's also security related. All the components you install somewhere, they need to be so secure, so hardened already, that just a component that you install. And there we already really trying to make more and more steps in that direction, but also then to handle the privacy regulations in the countries, what is allowed, what not, where we need to be careful what solutions we come up with the service provider, what is allowed in the country. And there we really do very fancy stuff at the moment. So yeah.
Okay. Well, maybe that leads us on to a possible part 2 in the coming weeks.
Yes.
But look,
look forward to it.
maybe we close at that. But I'd like to thank you guys for coming on, and I'm looking forward to working with you guys more. So we'll be seeing more of each other. But if anyone's got any questions, I guess they can leave them on the comments. Thank you everyone for joining, and I guess that's a wrap.
was exciting to be here. Thank you very much.
Have a great
Thanks,
rest of the
James.
week.
Thanks, everybody.